Hello engineers, welcome back. In the previous video, we got to understand what is an adjacency matrix in graphs. In this video, let's learn about adjacency list in graphs. Okay, I hope you're ready. Let's get started. So in this video, we're going to learn about adjacency list and we'll see how to code it in C++ and then we'll discuss time complexity, right? So let's see, what is an adjacency list? So let's take the same graph as we had yesterday. Let's say we have this graph, Sam, Tom, and Jerry, right? So in order to represent this in an adjacency matrix, we took a 2 by 2 matrix, right? Like this, 0, 1, 2, 0, 1, 2. And then we filled everything with zeros. And then we marked the edges. If there was an edge, we marked it as 1. Otherwise, we left it as 0. So this was the adjacency matrix. Now in this video, let's learn about adjacency list. Okay. So the only difference between the matrix and the list is, in a matrix, for every vertex, we were adding a new vector with the same size as the original graph, right? If they were 3 by 3, now it will become 4 by 4, like this. So this was consuming a lot of space, as we have seen in the previous video. Now let's improve that a bit. So instead of storing a matrix like this, instead of mapping every row with every column, we can do something little better. Let me erase all this. So these vertices are labeled, right? So Sam is on 0, Tom is on 1, and Jerry is on 2. So previously we were storing the relationship with every other vertex here. So instead of that, we will only store those edges where there is a requirement. For example, Sam is friends with Tom and Jerry. So we will store both Tom and Jerry here, 1 and 2. From Tom's point of view, there is only one friend, which is Sam. So from Tom's point of view, there is only one friend, which is Sam, which is 0. From Jerry's point of view, there is only one friend called Sam, which is 0 again, right? So if we store it this way, we are not filling the entire matrix like this, and every vector is expandable on its own. So if Sam got a third friend, we would have 3 nodes here or 3 vertices here. Otherwise, it would just be 2. So the size is not growing for every vertex. So if there is a new vertex, let's say Harry, so this is not changing anything for the previous rows. We don't need to alter the previous rows to accommodate zeros or anything like that. We can just leave it like this. And when Harry gets a friend, so when Harry gets a friend, we will simply add 2 to Harry and 3 to Jerry. So the size of Jerry's vector is only 2 now. The size of Harry's vector is only 1. And the remaining vectors are not disturbed, right? So this is the advantage of the adjacency list. So instead of maintaining a matrix, we can maintain a simple list and maintain only the edges, right? So what is the approach? The approach is, for every node, for every vertex, we will maintain a vector of what size? Size equal to number of edges. Simple. Okay. So if Sam is having 2 friends, there will be only 2 entries in Sam's vector. If Tom is having 1 friend, there will be only 1 entry in Tom's vector. If Jerry is having 2 friends, Jerry will have 2 entries in Jerry's vector, and the size will be 2. So the size is proportional to the number of edges. Okay. So that is how adjacency list works. So now that we have understood what is an adjacency list, let's code it in C++ and see how it looks like, right? So let's go to VS Code. So I created a new file called adjacency list and the base template is ready. We can get started. So let's create our graph. So let's create a graph class. And what do we need? In the private space, let's keep a vertex count. This will be helpful for us. And then now, instead of creating a matrix, we will create a list. So that will be vector of int again, but this time let's call it list instead of matrix. So it is still a vector variable, but we will not use it like a matrix. So let's create a public method. Let's first create the constructor, and we will initialize the vertex count to 0. So that is our initialization. Now let's create our first method for adding a vertex. So let's add a vertex. So for adding a vertex, what do we need? First, we will increment the vertex count. It was initially 0, now it will become 1. Okay, and currently our list vector is empty. So we will add a new vector, new empty vector to it. So list.pushback vector of int, and let it be empty. Don't give it any size, don't initialize it with anything, let it be flexible, right? And that's all we need to do. We don't need to alter anything for the previous vectors or anything like that. So add vector is simple. There is an empty vector. We will only add entries to it if there is an edge required, right? Now let's create a method to add an edge. So adding an edge, we have seen this before. We will take two things, int u and int v, which will represent the relationship between two parties, right? So what do we need to do here? So if I need to add this edge, Sam to Tom. So Sam is at 0, Tom is at 1. I will pass in 0 and 1, right? So u will be 0, v will be 1. And what do we need to do? From Sam's point of view, we need to add Tom, right? So in the Sam vector, we will add 1. In the Tom's vector, we will add 0. So in Sam's vector is in list of 0. We will add Tom. So here it is not 0, it is u, right? So Sam's vector will now have the value 1. Similarly, from Tom's point of view, we need to add Sam. Okay, and that's it. So let's see what's happening here. So first the matrix is very empty. We did the first vertex, we added Sam, then we added Tom, then we added Jerry. So we will add 3 vertices like this, which will be having empty vectors. Okay, so when we add the first edge will be between 0 and 1. So between Sam and Tom. So when we add 0, 1, we will add 1 to Sam and 0 to Tom. Okay, and then we will add 0, 2, which will be this edge, Sam to Jerry, right? So from Sam's point of view, we will add Jerry. From Jerry's point of view, we will add Sam. Okay, and these are our 2 edges. Okay, let's ignore Harry for now. If you want to practice, you can practice adding 1 more vertex as well. Now let's create our method to print this. Void print graph. So for printing, it is still a similar print as adjacency matrix because it is a 2D vector anyway. So let's print it. So let's do for int I equal to 0, I less than vertex count I plus plus. So this will give us the number of rows, and let's do cout I, and just for clear printing, let's give it an arrow. Okay, now let's do the columns. So for int j equal to 0, j less than, what we need here? We need list of I dot size, right? So we don't know the size of the ith row, right? So we are at ith row. So ith row can be flexible, right? It can have 0 or 1, or it can have million edges, right? So we don't know the size. That's why we are taking list I or list I dot size. Okay. Now we can print the edges for that row. So let's print list of I and j, and that's it. So we can do endl to finish the row, and we can do endl to finish the whole print, right? So those are our methods. Now let's create and test it. Graph G. So first let's add 3 vertices. Add vertex. This is for Sam, Tom and Jerry. 3 vertices are done. Let's print an empty graph. So it should not print anything. And we will now add 2 edges for 0, 1 and g dot add edge 0 comma 2, and we will print it again. Okay, I think that's it. Let's see. Okay, now we can see here, this is the first print. We have 0 1 2. These are our 3 vertices, and there is nothing on the right side, so there are no edges to anybody, so it is an empty graph, right? Now this is the second print. Now we have 1 and 2 for our Sam, and then for Tom we have 0, and for Jerry we have 0, right? So this is what we planned. 1 2 0 1 1 2 0 0 here. Sorry, this is 0 because we are edging with Sam, right? So that's it. That's how we can build an adjacency list in C++. Okay, now let's discuss the time complexity. So what is the time complexity? So for a lookup, if we want to look up any edge, let's say I want to look up if there is an edge between Sam and Jerry. So in a matrix, we would have done like this, I and J, right? Because we know the indices of Sam and Jerry. But now it is not the case. For lookup, what we need to do is, from Sam's point of view, we need to go inside the vector. We need to go inside the vector and keep looking for Jerry. So Jerry is 2, right? We need to keep checking if is there a 2 here in this vector. So if Sam has all the edges, if Sam is connected to everybody in the graph, then Sam will have how many edges? Sam will have O of V edges, right? V is nothing but number of vertices. So in the worst case, we would have to go through each and every vertex to find Jerry, right? So that will be the time complexity for a lookup in an adjacency list, right? Now what about space? So in the adjacency matrix, the space was growing at v square, right? For every edge, we were adding a new vector for a row, and then we were expanding the other columns. But here we don't need to do that. The space is proportional to the number of edges, right? So for every vertex, we definitely need to add a new row, so that is occupying some space, and every vector inside will carry some edges, right? So for this vector, there will be 2 edges. For this vector, there will be 1 edge. For this vector, there will be 2 edges. For this, there is only 1 edge, and so on, right? So this is the number of vertices, and this is the number of edges for that vertex, right? So generally, this is O of V plus E. So that will be the space complexity. So if we are saving a lot of space because we are not doing a V square type of expansion here. So the space is saved, but at the cost of lookup. For every lookup, we need to go through the vector and kind of do an iterative search on it. So linear search on this. So the space is saved, but time has increased. In the adjacency matrix, we were able to look up in O of 1, but there is a lot of space required, right? So that is a trade-off we need to remember when dealing with these two type of graphs, right? So that is it for this video, guys. So if you have any questions, definitely ask me. In the next video, we will try to look at the traversal methods. We'll start with depth first traversal. Okay, so thank you so much for watching, and do leave a like if you found this helpful, and comment if you have any questions or suggestions. Do subscribe to the channel and share it with your friends. Thank you so much for watching. I will see you in the next one. Cheers.